In this section, we take a look at some more advanced control structures. First, we consider the constructs break and continue. A break inside a do loop transfers control to the end. A continue within a do loop transfers control back to the loop header. Consider as an example the following program that traverses an array A. It computes the sum of all non-negative entries, except that it breaks as soon as a negative entry is found. The program graph constructed for this program is shown here. The key point is the edge from Q9 to the final node labeled skip, which is the one that corresponds to the break command. Once more, consider the program graph for our program with the break. In the general construction of a program graph, we need the following information. The start and end nodes, Q open circle and Q close circle, as before. An additional node QB to be the target for a break, and an additional node QC to be the target of a continue. As an example, for the test that if the array entry is negative, then we just update I with 1 and then do the break. The start node would be Q4. The end node would be Q5. The breakpoint will be the final node, and the continue point would be the node Q3. Now let us consider continue instead of break. Use the online tool to construct program graphs for break, continue, and skip. And let it construct a few execution steps. Some even more advanced control structures are throwing and catching exceptions. Here is a program that runs through an array looking for a certain value. If it is found, it throws exception yes. If the array is exhausted, it throws exception no. Otherwise, the loop continues. Then at the bottom there is code to catch the exception yes and code to catch the exception no. You can experiment with the program using the online system. To deal with these constructs, the BNF of the language needs to be extended as shown here. There is a new command for catching exceptions inside a command, and there is a command for throwing an exception. Exceptions are handled by executing a command for a given exception, and it is possible to have many exceptions to deal with. To generate program graphs, we need to generalize the breakpoint and the continue point to a handler environment that for each exception gives the node where the handler code starts. The details are in the book, and you should read the explanation there, and experiment with the constructs on the online system.